new log rule, well, new for unit 1, right? There's a new log rule that we had to focus on, right? And the rule is, well, we should, let's run through the whole one, right? If you had to convert from indices to logs, if you have A, C is equal to B, it becomes log to the base A, carry across the B, and that's equal to C. That's okay? Once you have it in logs now, we have to remember log, you have to remember that log of 1 is always 0. Same base, addition sign, you multiply. Same base, subtract sign here, divide. Right? Power rule, take the n, you could bring the n in front. Are you okay with that? Trying to figure out where this x ln x thing come out from. Anyway, suppose you have log log to the base e, right? Log to the base e of, let's say, 5. Log to the base e is the same as ln. So every time you see log to the base e, that's 5. Or every time you see ln, that's log to the base e. So if I ask you what is ln 5 plus ln 4, right? Because ln follows the same rules as log, all you have to do is say ln 5 multiplied by 4. That's okay? Are you okay with that? So every time you see log and ln, they follow the same rules. Okay? Ln is simply log to the base e. So, question. What is log to the base e of e? That's 1, right? So since log to the base e is ln, what is ln e? Ln e is 1. Right? What is ln e to the 5x? You can take the 5x and bring it in front here, right? So that'll be 5x ln e. And we know that ln e is 1. So the answer is 5x. So ln of e to the 5x is simply 5x. Are you okay with that? Yeah? How do we go from base A to base C? We can use the change of base formula, right? So if questions are not in the same base, we could use this formula here to change the base. Okay? So that'll be log to the base A, log to the base A. Sorry, new base, right? C, right? C, new base here. So it'll be log to the base C of B, log to the base C of E. Yeah? Right? So those are the rules. Now we have to be able to apply the rules. Right? Those are your log rules. Before I move on, how does the graph with E of x look? Or 8 to the x? Right? So the graph of y is equal to a to the power of x looks like that. And this here is the inverse, which is log to the base a of x. Okay? So it's important that you know what the graphs look like. What you will recognize is that this y value is never negative. See that there? That y value is never negative. Okay? And what about log? What about log? Can you find log of a negative value? No. So you recognize the log graph doesn't exist here. All right? Just some quick properties. So like when you're solving logs, if you have to find log of a negative number, you know that right here, you know that value doesn't exist. All right? So let's try a few and I'll give you a break. All right. Let's see what we got here. One more and then I'll give you a break. Too hungry or too hungry? Oh. All right, yes, now we're almost done. I'll give you a break after this one here. Right. The problem here, we had to make a substitution, right? So let's see what we have here. we have 6 minus 7 over 2 to the 2x minus 3, 4 to the 2x, right? Equals to 0. Right? Right, so we could also write it like this, right? 7 over 2 to the x minus 3. Remember, 4 2 to the x is same as 2 squared, right? That's okay? 4 will be 2 squared 2 to the x, which is the same as 2 4 to the x. Yeah? So that will be 2 4 to the x is equal to 0. All okay with that? Can I make a substitution now? Can I let y equal to 2 to the 2x? What will y squared be? What would y squared be? 2 to the power 4x? Yeah? So how will this look? So if I make the substitution now, what will happen? I'll get 6 minus 7 over y minus 3 over y squared is 0. How do I remove the fraction? Multiply everything by y squared. So I'll get 6y squared minus 7y minus 3 is 0. What's the next step? Factorize. How much you'll get? Anybody factorize it? How much you got? Y is what? How much? 3 and 2 and? Negative at it. So y is what? Y is 2 to the 2x is equal to 3 and 2. How is solving that? We can't come with the same base, right? This has no solution, right? Why does the right hand side have no solution? Sorry, the second value have no solution. Huh? Right, because you can't, indices can be negative, right? Yeah. How are we solving the left hand side? Take logs on both sides, right? So you'll get log 2 to the 2x, log 3 on 2. What about if it take ln? If it take ln, what will happen? Anything will happen? Nope. Get the same answer, right? So you'll get 2x is equal to log 3 on 2 over log 2. And then divide everything by 2. How much is that? Take log on both sides, carry across the 2x, and then divide everything by that. Yeah, and then divide by 2, yeah. 0.29. Okay, nice. All right, what do I do now? Give you a break now? All right, take a break. How long you want? 5 or 10? How long you need to eat? 15 minutes? No, not half an hour. That's too long. 20 minutes. It's 1 o'clock. I'm starting back 1:20 with questions. But we still have functions to do and alphabet and grammar. Plenty to do still. All right, online. The factorization, 3 on 2 and minus a third. All right, so solve it. Messiah, solve it. All right. Online, you'll have 20 minutes. Starting back at 1:20.
It's flip over and
Noble, everything here. Right, 1:20 we starting back, right? Those who don't want a break, continue doing the questions that did not correct it for you. Right, Sarissa? Sarissa don't want a break. Put all to the base. If we convert all to the base 2, you'll get log to the base 2 of x plus log to the base 2 log to the base 2 of x over log to the base 2 of 4 plus log to the base 2 of x all over log to the base 2 of 16. All right. Then we have to work on the denominator. What is log to the base 2 of 4? Right? Remember 4 is value 2 squared, right? And you can bring it 2 in front. So you'll get 2 log 2, 2. Casio people, you can just put it in the calculator and you will see that, right? What is log to the base 2 of 16? You'll get 4. What do we do now? What are you going to do now? Multiply everything by 4. That could work. So you'll get you'll get 4 log 2 to the x plus log to the base 2 of x plus log to the base 2 of x is 7. What's the next step? What's the next step there? Yeah, sorry. Thank you. 28. What's the next step? What's the next step? Can I factor out log 2 to the x? And I will get 4 plus 2 plus 1. Right? And then I could carry it on the next side. So I'll get log to the base 2 of x is equal to 28 over 7. So I'll get log to the base 2 of x is 4. And then solve x. That'll be x is equal to 2 to the power of 4, which is 16. Anybody got that? You didn't get to reach her? So you convert it all to the same base and work it out, right? Right, let's go again. That was 21. Let's check out 19. Try that fast. We kind of did one already. Try that fast. 19. That's 19. Oh, yep. Are you done? Finish already? This one? Right, let's see how it worked out. So we could convert all toward base. So we could convert the denominators to the base 9, right? So that'll be 4 over 3 to the, sorry, 9 to the x minus 4 over 9 to the 2x. Okay, is equal to 0. We can let y equal to 9 to the x, and y squared will be 9 to the 2x. So that's 3 minus 4 over y minus 4 over y squared is 0. Multiply everything by y squared, and you'll get 3y squared minus 4y minus 4 is 0. And the what are the solutions? Y is what? 2, 1 minus 2/3. Right? So it means that 9 to the x is 2, 9 to the x is minus 2/3. No solution, right? And here you take logs, so you'll get log 2 over log 9. How much is that? 0.31. Yeah?
0.315.
Sorry? 0.32. Yeah, Andy, once it comes around, you know, what you will do is